The next topic is the determination of a method of multi-biomarker in human urine by LC-MS. Dr. Koffrit is the reference contact of this method. And has been demonstrated that some potential marker for mycotoxin in urine includes the same mycotoxin, but also metabolite of mycotoxin. For example, a good biomarker for aflatoxin B1 in urine is aflatoxin 1. Ochratoxin A is ochratoxin A, you find in the urine ochratoxin A. And for deoxynivalenol, a good biomarker is the deoxynivalenol, but also the deoxynivalenol, the metabolite of the deoxynivalenol. And for the zearalenol mycotoxin, a good biomarker are alpha and beta zearalenol. For human B1 biomarker is the same mycotoxin. In our lab, we have developed an LC-MS method for the multi-mycotoxin biomarker by using a double cleanup, immunophytic column cleanup and SPA cleanup with Oasis column. And this is a typical chromatogram of urine sample after IAC and SPE cleanup in spiked human urine and naturally contaminated pig urine. Recovery are quite good, and also the relative standard deviation of the method, and the limited detection are very, very low. And within the microarray project, we have now to validate in vivo this method by using animal model and in collaboration with Gordon Shepard, also in human model. Another topic is the proficiency test for LC-MS multi-mycotoxin method. This project was within the MONIQUA project, and the aim of this study was to obtain information on the use LC-MS methodologies for multi-mycotoxin analysis and relevant performance in the European laboratory. 63 laboratories were contacted, and participants analyzed the following material using their LC-MS methodology. One mice sample contaminated with aflatoxin OTA, ochratoxin A, deoxynivalenol T2, HT2 toxin, zearalenol, and phimonicin, and one blind mace sample for recovery evaluation. In addition, we provide Calibrant spiking solution test material to analyze. The study has recently completed, but results are under evaluation. We have also some experience in rapid method for analysis of mycotoxins, and in particular, we have developed a multiplex dipstick immunoassay. The current method, lateral flow dividing dipstick, commercially available, are for the single mycotoxin, for aflatoxin, B1, and phimonicin in maize, for deoxynivalenol in wheat, for ochratoxin A, zearalenol, T2, and HT2 toxin in cereal grains. And the possibility to use the readers allow quantitative analysis. Within the confidence project, we have developed a multiplex dipstick that allow the determination of zearalenol, the sum of T2 and H2 toxin, deoxynivalenol, and the sum of FB1 and FB2. On the strip are immobilized the toxin conjugate each line is a toxic conjugate compound, and in the control line is immobilized and built-in GSR conjugate. When we add at a negative solution, blank solution, labeled antibodies, the antibodies don't find mycotoxin in the solution, are free, and they can bind the mycotoxin on the strip. So the strip, the test line on the strip will be darker than the line of the control. When the sample is contaminated with mycotoxin, the labeled antibody binds the mycotoxin solution. So the only antibody that is free is the antibody that binds the control line, the analyte in the control line. The strip, the test line on the strip will be lighter than the control line. The method that we have developed has a total time of analysis of 30 minutes. You need an incubation of the strip at 40 Celsius degree, and in this figure show the first is a negative sample. All lines are darker than control line. And this is a positive sample for zearalenone. This is a positive sample for zearalenone G2. This is a positive sample for zearalenone G2 and DOM. This is a positive sample with all mycotoxins. The method is a semi-quantitative method. We have chosen a cutoff level, depending on the toxin, but also fixed at target level corresponding to 80% of the European. This is what chosen within the project. And we observed a good agreement between results obtained with stick and results obtained with CMSS analysis. The dipstick is negative or is positive for zearalenone, where the cutoff is, for example, 80 ppb. In addition, we have some experience with fluorescence polarization in assay. Fluorescence polarization in assay is an homogeneous competitive fluorescence in assay. This afternoon, Professor Guerrier will talk in more details about this technique. We have developed a method, a good method, for the determination of dioxinate, nivalenol in wheat and wheat based products. And the detection limit of this method was 80 ppb. The recovery are very good because no cleanup of extract are necessary for this immunoassay. The time of analysis was less than 10 minutes. And a good linearity range was obtained between 80 ppb and 2000 ppb. For concentration higher than 2000 ppb, a simple dilution step is necessary. You don't have to repeat the analysis. And this is a good correlation that has been observed when 147 samples contaminated by dioxinnivalenol were compared by HPLC and by FP. In addition, we have developed a robot, an automated system for the determination of mycotoxins is the same and is very easy to use. And this could be a good, useful alternative to HPLC because you can analyze more and more samples per day. This is the last slide, and the method that we have developed in collaboration with Professor Remy for the determination of mycotoxin A in wine, in red wine. This method needs an additional step of purification because the extract is very dirty, the matrix is very dirty, and we found an aminopropyl phase is good for ethanol. Thank you. This is all.
Thank you very much. Есть какие-то вопросы? If any question, please don't hesitate.